I left us right here last time. And I don't know, I've been, this week, I'm sort of on the attack against nutrition labeling, or rather in favor of stronger nutrition labeling, so Americans can actually make informed choices about what they're eating. You'll see that today when we do the elemental analysis lab, presuming that I finish writing it up after class here. So my point that I was making last time that we spoke is that not all fats are made the same. And just saying polyunsaturated or monounsaturated, even though that is a higher level than labeling than we currently have, still is inadequate. If we begin to tease apart the polyunsaturated fats, which without going to some sort of primary literature, you're never going to get from the basic nutritional labeling. So I was making the point that the labeling, to know if whatever content of unsaturated fats, whether they're poly or mono, you have to get that by inference from the total, subtracting the saturated fat from the total fat. And it doesn't tell you anything about poly or mono, and then what types of poly. So the point being is that labeling, nutrition facts labeling, is rooted in misconceptions that were established in the 1970s. And beyond that, it's geared towards telling people what's bad for them in the foods, right? So what do we have here? It's telling us that there's no trans fats in butter, in this label. I don't need to know that there's no trans fats to be able to make a health positive choice. It helps me not make a health negative choice, but if I want to make a health positive choice, saying, oh, I would like omega-3 fatty acids in my diet, I'd like to make a health positive choice in terms of that. There's no way you can make that kind of choice without knowing further information than the food is actually providing you, the producer of the food is providing you. So this labeling scheme I'm showing you here, where we see these color bars, you could have, for butter, for example, you could have just that labeling color bar in there in the nutrition label, where it actually showed you a breakdown, a visual breakdown of the amounts of those different types of fats that are actually in the food. All right, so when we're looking at this spectrum of different kinds of fats that are there, they sort of run from the saturated fat, which are more animal-based fats, fats that are vegetable fats that are grown in the tropics at high temperature, and they have a higher melting point, meaning that these fats tend to be solid at room temperature. Has anybody ever cooked with coconut oil before? Seen coconut oil? What is that like? It's,
I mean, I guess
it's a white solid. It's a white solid in the winter, and then in the summertime, it usually turns to a clear oil, a liquid, right? It liquidifies.
what's like
Ghee is clarified butter, so it's just a processing. It's a way of them processing the butter and pulling out protein. So, and then the other end of the spectrum are these polyunsaturated fats, the most extreme of them being like EPA and DHA, those heavily unsaturated fats. So these, the polyunsaturated fats are all of vegetable origin. They're grown in temperate climates, and they have a very low melting point. That is to say that they are oils at room temperature. They're oils at room temperature. They're also heat unstable. They tend to be oils that can go rancid at higher temperatures. For example, flaxseed oil, or has anyone ever had flaxseed oil? Has anyone ever tried hemp seed oil? That's a common, or it's becoming more common. These kinds of oils should be kept in the refrigerator if you're going to consume them. So what is the origin? I want to look at this melting point temperature, whether the fat is a solid or a liquid at room temperature, and try to understand that in terms of the structural biochemistry of those fats. All right. So on one hand here we have these saturated fats. So pull this thing out. Look at this mess. Oops. Fats are degrading. So on one hand would be a saturated fat, like this. You. And then on the other hand, this would be, here it is, this is an omega-3 fatty acid. So there's 2 degrees of saturation in this. This would be like linoleic acid, something like that, or linolenic acid. Yeah, you can pass them on. But as you look at them, you'll notice the saturated fat is like, hold the 2 of them up from the red. Which one's longer? Hold them side by side. Which ones seem longer to you? The saturated fat. The truth of the matter is they are both exactly the same number of atoms. They're exactly the same number of atoms. They should be the same length. And the difference between them is that the unsaturated fat has those double bonds in it that introduce kinks in the fat. All right? And make it so that the fat cannot extend to its full length. It reduces the degrees of conformational flexibility in that molecule. It reduces the degrees of conformational flexibility in that molecule. So because of that, when you are packing into a membrane, for example, or whenever they're next to one another in bulk, the saturated fats, because they have more conformational flexibility, they're able to pack together tighter. They can figure out how to move together in a room better. So a couple of you guys are dancers in the room, right? And you're into body movement. Imagine if you had a stage full of people that were all standing around like this. This is how they were, right? And you weren't allowed to move. That was the shape that they had. How many people could you pack into a stage or an elevator, say, that all had to be standing like this? And then compare that to a bunch of normal people who can move their bodies like this and sort of,
Jesus.
Here I come. Oh my God. Graham. Okay. Great. So, sorry. Didn't mean to scare you. But the point I was trying to get at there was being able to adjust your body to those who are around you. I'm sorry I invaded your space there, Graham. Okay.
I'm over it.
Okay.
It's a traumatic few seconds.
Okay. Oh, man. Traumatizing my students.
That could be a lab.
Traumatizing students. I feel like all my labs are traumatizing students. Okay. So these unsaturated fats are not able to pack in as much together, and because of that, we've talked about the only real I guess I did talk about a couple different forms of intermolecular forces, right? When we were talking about proteins, I talked about hydrogen bonds and polar interactions, but I also talked about hydrophobic interactions, where greasy amino acids like to come together and had that the attraction of like and like were coming together, hydrophobic interactions. Well, in these saturated fats, I probably need to get a better color here, but this light yellow in between here is meant to be represent hydrophobic interactions. There's a much higher density of hydrophobic interactions in these saturated fats than there are in the unsaturated fats, and that's because the unsaturated fats have these kinks in them. They are fighting against those double bonds in terms of packing together and reducing the amount of hydrophobic interactions per volume in that fat is going to lead to something more fluid, a more fluid molecular state. Increased hydrophobic interactions in the saturated fats leads to a less fluid, more solid state. This is why butter and coconut oil or palm oil looks like this, whereas canola and that kind of stuff, flax oil or whatever, looks like this. Now, questions about that. So if I asked you a question, what is the origin of the difference between fats and oils, fats being solid, oils being liquid, what would you say? Say, it's Friday, I want to go home. What's up? And you'd get an A. Okay. So here's an example of that. Here's some actual data. If we compare lard, which is just rendered pork fat, and butter fat, coconut oil, and then we go in the other direction, cod liver oil, olive oil, corn oil, we can see this gradient of melting points. So lard, when you keep lard, it actually is stable at room temperature. I've got a tub of lard in the lab that I've had since last year. And it's solid. It's fine. It doesn't smell any better or worse than it did last year. And if I were to take it, so room temperature is like 22 degrees C. If I were to heat it, put it in a, not much, doesn't have to get heated much, but if I were to put it in a warm water bath, it would turn liquid. And that has 41% saturated fats, all right? And a large percentage of it is actually monounsaturated, and then a little bit of polyunsaturated fats. And then we go down, let's go intermediate here, coconut oil. It turns fluid at 25 degrees C. So that's like a warm, not necessarily even hot, but a warm summer's day. If you keep coconut oil and you want it fluid, a good place to keep it is in the cabinet above your stove because it tends to be a little bit warmer up there. And that way it's going to be close to its melting point. Coconut oil is mostly saturated fat, 92% saturated fat, a really high degree of saturated fat. And so you may ask, well, look, if there's less saturated fat in the lard, how come that has a higher melting point? It also has to do with chain length of the saturated fat, right? So, I was back here, I was talking about a better way of labeling, for fats. Even these color bars that I'm showing you here are in some ways inadequate to tell you what kinds of fats. There are, even within the family of polyunsaturated fats, omega-6 fatty acids, there are a number of them that are going to have different chain lengths and which are going to lead to different physiological effects, metabolic and physiological effects in the body. All right. Questions about this? Why do fats not go rancid as quickly? Well, first of all, when you have the saturated fats, you don't have the double bonds, and those double bonds are very temperature sensitive, right? And they can go from cis to trans fats, and saturated fats don't have that problem, first of all. And then secondly, rancidity really is about spoilage is about bacteria, and bacteria like consuming the fat for energy and making the fat go from a long fat to a shorter chain fat, which is what smells nasty. I don't know if I'm going to have time this semester. I would like to in lab. I did it last year. Maybe I could do it. I'll see if I can fit it in. But I did a lab where I had a whole bunch of different pure fats, pure fatty acids, and I had everybody sniff them and write down what you smelled. And I have some of these short chain fatty acids, which smell terrible. They just smell terrible. They're not bad for you. They just smell gross. And I think I told you this before. Our body has So fats in the solid state, bacteria have a harder time gaining access to those fats. The other side of rancidity is oxidation, and so oxidation. So these fats can get oxidized and give rise to oxidized intermediates that our body, our sense of smell, finds repellent. And again, a fat, something that's solid, is going to have a harder time getting oxidized than something than a liquid an oil that's able to freely move and move around in the liquid state. I was going to make one other point. Oh, so for example, have you ever seen, like at your grandma's house or something, some people have, maybe your parents have it, I don't know, like it'll be a jar, one of those ceramic jars, and then there's like a cup with a handle on top of it that sits down in the jar, and you keep a little bit of water in the bottom, and then there's butter in the cup. And you set the butter, so you can keep the butter at room temperature so it's spreadable, but it excludes oxygen from the butter because it's sitting upside down in the cup of water or whatever. That's just to prevent oxidation. Any other questions? Good questions. Deep thoughts? No? How is everybody doing? Y'all ready for the weekend? Seems like. Yeah. We got 1 month to go.
Really?
Mm-hmm.
How close are we? What is this?
Today is the 12th, and our arsenic forum is on the 10th, so we're a month away.
Oh my God.
Yeah. Okay. Oh, did I forget my phone?
I can't wait. Is that a natural process?
What's that?
Converting liquid vegetable oil to solid fat.
Converting liquid.
Can the body do that?
The body can interconvert fats and oils. Absolutely. All right. So, but we can also do it. We can also convert saturated fat or unsaturated fats into saturated fats industrially. And you guys have probably heard of hydrogenated fats or hydrogenated oils. Have you heard that before on the shelf? So hydrogenation is this process where you can take vegetable oil that is liquid and convert it into a semi-solid fat. And this is one of the things that happens in like margarine, for example. Margarine is made of vegetable oil, which is a liquid, but then they hydrogenate the saturated or the unsaturated fats in the vegetable oil and make it saturated. Yeah, what? So that you can get this kind of profile. So here's butter fat. This is what butter fat is like. All right. But maybe you want butter fat that's vegan. Maybe you want. Yeah, that's what margarine is. It's people trying to imitate butter, and it's back when that was originally created. It was not, the story behind margarine is not in service of vegans, because margarine wasn't created when vegans were a thing, but it was it was seen to be a cheaper form of spread than butter. It is, because you're just making it from vegetable oil, whereas butter is pretty comparatively expensive, you know. And then, yeah. Mm-hmm. Yeah. So there's canola is a very common one. That's the rapeseed oil that we were talking about. Corn oil is another. You know, when you hear vegetable oil, it's usually either safflower, corn, sunflower, or rapeseed. One of those. Yeah. It can be soy. Soy is often an additive. I guess I told you guys about how some lower quality olive oils from Europe that get exported to the United States are adulterated and not pure olive oil. Yeah. The fat profile in butter fat is not exactly the same as that of margarine either. And the thought was that you can increase the amount of saturated fats to make it solid and to give it like a flavor profile similar to butter, but you can have a higher percentage of healthy polyunsaturated fats in it, so it's meant to be healthier for you. But again, I think this is rooted in 1970s and before food science notions of health and nutrition. Anyways, this is what it is. So you can take oleic acid, which is the oil. It's like 40%, 50% of the oil that's in peanut oil. Something like 60% of olive oil is this oleic acid. And you can take this and convert it to stearic acid, which is essentially oleic acid minus this double bond. And the way that happens is you take the fat and you expose it so you have this metal catalyst, either nickel, palladium, or platinum catalyst, which sounds expensive, but it's not, because it's a catalyst that can get used over and over and over again. Once you've built it, it's good relatively indefinitely. You flush the surface of that metal with hydrogen gas and adhere hydrogen to it, and then the metal catalyzes the addition of that hydrogen across to the double bond, thus saturating it. So that's what you see in that panel on the right-hand side. Well, this sounds good. I can make a bunch of partially hydrogenated, I can make a bunch of hydrogenated fats to get vegetable sources of animal fats, and maybe have, if I do a partial hydrogenation, if I don't hydrogenate all of the fats, then I'll have like a better profile of polyunsaturated fats than I would get out of butter, but I would have like all the benefits of butter, like the taste and the solidity and et cetera, right? And it's like resistance to rancidity. The problem is when you partially hydrogenate a fat, meaning when you don't take it to completion, one of the things that happens is the creation of trans fats. So that platinum disrupts the double bond. Not enough, if it's happening partially, there's going to be a subset of the molecules that the double bond was disrupted, not enough to add hydrogen, but just enough to let that cis double bond flip to a trans double bond, which is genuinely not good for you, right? So, partially hydrogenated vegetable oil, while it's commonly used, so like fryer oil often has partial hydrogenation to be able to increase, it increases the smoke point of it and allows it to be used to cook at higher temperatures, but it increases trans fats. So this right here is one of the reasons that beyond simply the effects of high temperature on the fats, this is also one of the reasons that deep fat fried foods at like wherever your favorite fast food joint that's taking over a strip mall near your house, that that fryer is bad for you, not just because of high temperatures, but because they're using these partially hydrogenated fats and oils. Yeah. Peanut oil is not if I were deep frying something, which I try to like be able to run up the hill of Miller to make it to class sort of on time as long as I can in my life, keep the peanut oil limited. But if I was going to deep fry, I would probably prefer to do it in peanut oil. In fact, when I was trying to get my kids into fish, we did it by I made fish and chips, right? And so had a little like one of these countertop fryers, and I would get peanut oil and fry stuff in that. It is more expensive, certainly, and it is deep frying things is not good for you, period. But I think peanut oil is going to certainly have less trans fat in it than like unprocessed peanut oil is not going to have the trans fat that a partially hydrogenated vegetable oil will. And so from that perspective, it is a better thing for you. I mean, things in moderation. We could go through this class, and I haven't really geared this class to be exclusively about telling you what the right thing to do is. Like, I don't want to tell you what your diet should be. Everyone needs to have agency to be able to make food choices on their own. All that. I'm just trying to give you information. But, and so with that being said, I think, things in moderation. You want to eat some deep fat fried food, go for it, But being aware of what that choice is. I feel like a lot of Americans don't even really, they vaguely know that they shouldn't be eating a lot of that kind of stuff, but they don't really know much about it. They're not really able to make health positive choices because they don't have the information. So my goal here is to give you information to make health positive choices. Yeah. All right. Any other questions? So, trans fats. Yeah. Coronary artery disease and myocardial infarction. Has this touched anybody's family? Has anybody in the class had this in their family anywhere? Grandmas, grandpas, moms, dad, cousins, uncles, anyone that they care about? No, just a few. This is less than I would have guessed. Everyone on my father's side of the family, to the person, has dealt with this. These statistics are actually not super duper new. This is 2009. This data is a decade old. Around 1 million people a year die of heart disease in the United States. is the current statistic. And it is about 25% of all U.S. deaths. That's staggering. That's staggering. All kinds of stuff, man. Cancer. You know, this is a complete tangent, but maybe this will be interesting to you since this is a class of non-majors, so it is still science-y. By the year 2050, which is by the year 2050, you guys will be my age. By the time you are all my age, they say that antibiotic and antifungal resistant pathogens will kill more people than cancer worldwide. That means more people will die of bacterial and fungal infections that are resistant to the antibiotics and antifungal medication that we have to treat them than people will die of cancer. And that is, it's a little bit deceptive because they project that cancer rates are going to go down because of improved treatments, but not as radically as antibiotic-resistant deaths are going to go up. So, yeah. Oh, man, that's a whole, like, we could do a whole class on that. Course on that. But the short answer to that question, again, going further down this tangent, is there's a lot. One of the things actually kind of does relate to this. You may have noticed when you go into the store to buy chicken or beef, it's you can, like, if you buy the boutique stuff, it says not treated with any antibiotics or growth hormones or any of that. They learned long ago, back in the era of, what was the competition for the chicken again called? Remember? What's that? The Chicken of Tomorrow. In the Chicken of Tomorrow era, they learned that if you feed livestock, poultry, and beef in particular, or pigs, if you put antibiotics in their feed, that they grow bigger. They just put on more weight. And so it's fairly common practice in industrial agriculture to use antibiotics on the chicken and the beef, and then on the antifungal side, they put fungicides. They spray that all over the crops. I mean, fungicides are on par with pesticide use in agricultural production. And when you dump that much of something on, like, we like to think that humans rule the world. We're just living in this little blip. It's like a party time for humans, but party is got to end eventually. Like, the planet is dominated by prokaryotes, right? Little bacteria, microbes. There are something like 2 orders of magnitude more prokaryotic cells in and on your body than human cells of your own origin. So, like, just by sheer number of cells, you are more bacteria than human, which is something to contemplate in the dark of night. So that is one of the major sources of antibiotic resistance and antifungal resistance. Okay, so no, yes, but that's not the problem. So that's trichophyton. The antifungal, the fungal problem is called, the big one that's antifungal resistant is called C. aureus. It's, I forget what the C stands for, but it's a type of yeast, essentially, that can invade your mouth and then your body, and it's something like 40% fatal to people who contract it. It is people who are of compromised immune that are the most susceptible to it. So that is children, particularly newborns, the elderly, people who are under chemotherapy, and people who are like have other immune compromised conditions, like types of immune cancer, like lymphoma and HIV and stuff like that. And and like organ transplanters who are on high dose steroids, those kind of people are all really in danger of this. And one of the problems with this issue is that hospitals, you bring it into a hospital, it is super hard to get it out of the hospital. It's really hard, much harder than eliminating like a MRSA infection, an antibiotic-resistant infection. This stuff, you get it into a hospital, and in many cases, they have to virtually rip out the ceiling tiles and pull up the floor and pull off the walls and completely remove all that material. They've done things where in these hospitals, they've sterilized the room, tried to sterilize the room. They put a peroxide vaporizer in the room to get into all the cracks, and then they put what's called a settle plate. It's a culture plate in the middle of the room, and whatever settles out of the room lands on the plate, and they grow it. The only thing, after doing this peroxide mist and the whole business, the only thing that still grew were these C. aureus cultures. So, yeah, the epicenters in the United States for these infections right now are Chicago, New Jersey, and New York. Those are the three places where they've had real problems. So, and it becomes an even bigger problem because the hospitals do not like to publicly report that this is a problem, because then they don't want to create a panic over something that the patients can't control, and then like have patients not admit to their hospital. So there's like this. The public health crisis is exacerbated by a lack of reporting on the part of hospitals that are dealing with these. Like hospitals and nursing homes are the two places that become really that particular fungal problem gets really concentrated. But it has, what is it, like 70,000 people in the United States. We're talking about myocardial infarction, but with time that antibiotic and antifungal resistance is going to be a problem in your lifetime for sure. Probably take people like me out. That's probably how I'm going to die. I don't know. Someday something's going to take me out. Okay, so what's the cost of all this? I got sidetracked there. It's about $1 billion a day. And so that statistic was not 2009. That is a little bit newer than that, but it's still probably about 4 or 5 years old. $1 billion a day. $1 billion a day. If we could just deal with this problem for a week, then our administration could build the wall that they want. This is a huge amount of money. It's a huge amount of money, right? This is a national emergency. This is what real emergency looks like, in my opinion. A lot of people are dying because they are not able to make health positive choices in terms of the sorts of fats that they are eating. The fast food, the easy food choices that we have in our culture are not choices that are to the benefit of the broader population. All right, thoughts on that? Me preaching here. I've been preaching. Thoughts, please don't be shy. You don't have to just parrot me. You can come back at me. Yeah.
Is this like something that went from 0 to where it is now? Or is it directly to fast food? Or like would there be some cases of
atherosclerosis, yeah. Yeah, so, this is evolution, right? So if there is, in any population, you're going to have, a certain subset of people that are going to get atherosclerosis, right? There's going to be some people. And if it happens to them really young before they are able to procreate, then those genes that made them more susceptible to this don't get passed on, right? But when you have 25% of the mortality in the United States due to that, then something is out of whack. There's a disconnect between the diet that we have that is trans fat, that is, I haven't given the fructose lecture yet. I eschewed the fructose lecture. Maybe I'll give it later in the semester. But when we have a diet that's all trans fat and fructose, there's a disconnect between that and the fundamental biology that has evolved over the millennia that has led us to this point. And maybe if we introduced this kind of food more slowly into the food chain over the span of centuries, maybe our biology would adjust to, like, being able to deal with pizza and hot dogs better. But that's not what happened. It was a rapid advent. Really, within like 2 or 3 generations, this food has just like blasted onto the human populace.
Is there any way to brush your teeth?
Oh man, yeah, right. Like the arterial toothbrush or something.
Oh, I thought like actual teeth plaque could affect your.
No. That's the cross section of an artery, and what happens is these things called foam cells. They're like macrophages that have absorbed certain kinds of the chylomicrons, which are types of lipoproteins in your blood. They form these plaques. I don't know, man. If you could answer that question, you'd be not needing to sit in this class. This would be your golden road. There are all kinds of different thoughts on that. Some people say like garlic, eat lots of garlic, right? And that can reduce plaque buildup. But once that plaque is there, I think it's pretty hard to mobilize it. All right, so shit. I wanted to talk about. Oh, I swore on tape. I want to talk about triglycerides. I do have 1 minute left. So why don't we pick up on Monday, and I'll talk a little bit about triglycerides, then I'll try to move on. I don't want to get stuck in fats too much more. I got sidetracked today. We'll finish up with triglycerides. I'll cut out some of the other stuff that I was going to talk about, lipoproteins, and then we'll move on. I'd like to get to some micronutrients. I'd like to talk about the Maillard reaction with you guys. Maybe caramelization, maybe some like actual cooking chemistry, and then we'll be at the end of the semester.
Are we gonna